Students, in today's class, we will discuss some numericals from your waves chapter. Okay, but before moving to the waves chapter, waves numericals, let me discuss just few theories with you all. Okay, because you have already read all these theories when we were discussing in the theoretical classes, but since all the sums that I will discuss in today's class, most of the sums, not all, are depending on these just two very small theories. Okay, so just repeating it once so that it comes in your mind once again and you can do the sums. Okay, so first thing, that is from the waves chapter only, discussing the concept. You have learned the what do you mean by the term phase of a wave, isn't it? Phase of a wave at a point x at any time t is given by a particular equation. This you have learned. Okay, that is, I'm just writing this particular equation again. That is phi equals to 2 pi within bracket t by big T minus x by lambda. Okay, this is the usual form of phase of a wave at a point x. This is the x. At time t, this is the small t, don't consider the big T here, is given by this particular equation. And in other form, how you can express this phase as 2 pi within bracket Vt minus x. Okay, Vt minus x. You can see all these equations and all we have discussed in the classes, in the theoretical classes. Okay, so this you already know, the phase of a wave. Okay, now students, I will discuss that phase change with time. How does the phase change with time? That we will discuss right now. Okay, so phase of a wave at a fixed point, let us consider this a point x as the fixed point. So the phase of a wave at any fixed point, suppose consider here at as x, changes with time. Okay, so as time changes from t to t plus del t, that means time is becoming from t to t plus del t. The time is changing in this interval. So the phase of the wave changes from phi to phi plus del phi. That means your phi is also changing from phi to phi plus del phi. Clear? So from this particular equation, from these two equations of phi, what we can write? That your del phi equals to 2 pi by t del t. Clear? So this we are writing when all this, that means t's and phi's are changing with this interval, means from t it's becoming to t plus del t. Same case for the phi also. Phi is also changing from phi to phi plus del phi. Okay. So if your del t, that means this small del t is your big T. Just imagine, if your small del t equals to big T and phi equals to 2 pi. Okay. So thus the phase of a wave becomes the same after changes by one full period. Have you seen, students, that the phase of a wave is becoming the same only after the time is changing by one full period. That means this we have considered here. Okay, so this was a very short concept of how does the phase changes with respect to time. Okay, the concept already you have learned. Now students, I will move to the next part of this phase change, that how does the phase change with position. This was all your phase change, that means all these theories was your phase change with time. Clear? All these parts till here. Now we will see the phase change with position. I am writing here only phase change with position. Okay, so let's see what's written. What we can learn from this part, that how does a phase change with respect to position. Okay, so what you have to consider in the beginning, that at a particular instant of time, just consider here as small t as the time constant. So what will happen to the phase? The phase of a wave changes with the position x of the particles, obviously. Since you are considering t as your constant, that means small t is your constant part. So if this you are keeping as your constant part, so obviously the phase of a wave changes with the position x of the particles, isn't it? It has to change. Now just consider that two particles are there, and whose mean positions of, that means mean positions of the particles are at, I'm writing here, are at x and x plus del x. Okay, so these are the what, these are the mean positions of the particles that you have considered. Okay, then the phase difference between the two particles at any instant of time can be obtained from this particular equation, that means this equation, isn't it? Okay, this equation we are terming it as equation number 1, this one. Okay, so yes, so phase difference, that means we are denoting it by del phi. Okay, so del phi will be what? Repeating once again the statement. The phase difference, that means your del phi part, okay, between the two particles that you have considered the mean positions as x and x plus x dash, okay, at any particular instant time t can be obtained from this particular equation. Clear? So let us write that particular equation. So del phi will be equal to minus 2 pi by lambda into del x. Okay, okay, so now you can ask that why I have written this negative sign. So the negative sign here indicates that for a wave traveling in the positive x direction, just remember the graph that we have done. Okay, particles having higher values of x